do you make it more resistant to bending? Material still the same. Design requirement, as in the width, is still the same. What am I doing now? What do we start to do? We start to incorporate what we are learning now, known as a manufacturing process called bending. That's why manufacturing process is so important. Yes or no? We start to what? What are we doing? We start to bend the structure. And now the structure is stiffer. But it's still very easy to what? It's more resistant now. Can you see that? Right? It's more resistant. So you see that? The material Young's modulus did not change. This is the material that your company buy. Dimension the same. This one you put 5 cents of work. This is easy to bend. This is not easy to bend. More resistant. Okay. Now, next we come to think of this, okay? But rather than that, we want the structure, the side pillar to be in this orientation. Deliberately. And why is that? And paper support my wallet. Young's modulus still the same, length still the same. When I put on top, what happened? It will crumple. After 3MF3, we know a manufacturing process, we start bending. Young's modulus still the same, strain hardening is still the same, thermal sensitivity is still the same, but it can withstand the what? This is what manufacturing is about. Are we clear? It's not just like, oh, the frame, blue color, 800. Are we clear? So why did this structure did not come down? 3ML3, strength of material. What happened? What did we do by folding? What sort of geometry did we change? Yeah. What is it's known as second what? Second what? Second moment of area. Not second moment of inertia. Two different things. Symbol is the same, but the meaning is different. Are we clear? Okay, we change the what? Second moment of area. Second moment of area increase the resistance to what? Bending. Now coming back to here now. Okay. So now you can see what is the purpose of the what? Why is the front side pillar oriented in this direction and not in the other direction? What did I show you? Right? When we do this, it is quite easy to bend. When we do this, right, I can support my wall. So what does this show you? What did we increase? You learn this in static and dynamics. What did we increase? You always got your mechanical vibration. Yes. What did we increase? We increase the speed. Young's modulus is still the same. Agree? But we just increase the what? Speed. We clear? Okay? Then your guess, when I'm an undergrad student, what subject did I do worse? Huh? Which subject did I do worse? Okay. Did I tell you this before? Yeah. So whatever you do worse, shut up. Okay. They make you teach 3 hours at night. Are we clear? Okay. I so love strength of material, but anyway. Right. So it's to transmit the load or energy to the front. So I will give you example. Okay, I will give you. So what if, okay, I buy the bumper beam okay, from a friend whose father owned a business that is dual phase steel, what will happen? Because he's my best friend. It's like Justin Trudeau running the country. Yes or no? What will happen? Okay. So now, in real life, okay, I'll draw for you the effect first. I draw for you the effect first. So we are going to compare two diverse material. Okay. So one, over here, this is AISI. No, we use dual phase, for example. Then on the other one, we use what? And now you can appreciate why I deliberately draw one steeper than the other. Yes or no? Right? Then I'm going to assume constant stress. Okay. We're going to assume constant stress during what? Impact. So what you have over here, you have the strain of what? Dual phase what? Steel. And over here, you have the strain of Usborg. Okay. The purpose of the what? Of the bumper beam is to transmit the load, not to absorb any energy. Right? So energy, the area under the stress strain curve is what? Is energy. So if you look at Usborg, this is the amount of energy that is absorbing during the impact. Okay. And then the other one, I will highlight. This is the amount of energy it will absorb with what? It might even break. Sorry, with dual phase steel. The structure might even fracture. Are we clear? So the bumper beam, do you want the bumper beam to break? No. You want the bumper beam to be what? Don't deform at all if possible. Okay. Now you can replace this with aluminum. Okay. But is it necessary lighter with aluminum? You got it there. Yeah, because you have to what? For aluminum, right? To be able to have that high stress, stress is equal to what? Force divided by what? Area, right? So to be able to withstand that high stress, the area has to be very, very what? Big. So your car will look like a truck. You get where I'm coming from? You can, no aerodynamics advantage will be given to you. Are we clear? Right? So if we were to make this of dual phase steel or from Usborg, okay? And if this were to be the wall, okay, over here, this is our what? This is the wall, right? Upon impact, what I'm drawing down here is the what? Is the bumper beam. Okay. And what happened to the bumper beam? Okay. So if we look at the bumper beam, so down here I draw staggered like this. Okay. And this is your what? front side pillar. So what you want for the bumper beam, little deformation. Okay. Little deformation and transmit the energy to the what? To the front side pillar. Okay. If you are to use dual phase steel, okay, if dual phase steel is used, or when dual phase steel is used, okay, the front bumper or the bumper beam might what? Might fracture. So fracture means what? Okay. If fracture, okay, this is exaggerated. Okay, this is exaggerated. Fracture means what? Your bumper beam breaks and it will start to look like this. And this is the fracture of bumper beam. When it fracture, it will fail to do its purpose of transmitting the load to the what? Front side bumper. Be clear. Okay, so we use, so like what you all say earlier. Okay, so for front or bumper beam, Usbor 1500 is the preferred material due to high A, B, and N values, which reduce, okay, which reduce what? Plastic strain and energy absorption. Okay. Most important is to what? Transmit the energy upon impact to the what? Front side pillar. Are we clear? Okay. So we have to be careful. Whatever we learn from the internet, this is a typical. At one stage, I asked this question to my students. This was in 2016, and they come out with different answer. Okay, and they told me recommendation from internet. Yeah, right. Are we clear? Okay. Go for how many minutes you need a break? Tell me. I'm negotiable. 10 or 15? Okay, go for 10 minutes break. Go and smoke something to make you high and then come back. Okay, we will come back